Subscribe to our channel, and hit the bell icon, to never miss a video from us. AWS Networking. AWS offers networking capabilities, required to run any workload in the cloud, with security, availability, performance, global coverage, and manageability. First is, Amazon Virtual Private Cloud. With Amazon Virtual Private Cloud, you can launch AWS resources into a virtual network that you define. This virtual network closely resembles a traditional network operated in a private data center of your own, with the benefits of using the scalable infrastructure of AWS. Amazon VPC is the networking layer for Amazon EC2. The following are the key concepts for VPCs. A virtual private cloud is a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud. You can launch your AWS resources, such as Amazon EC2 instances, into your VPC. You can specify an IP address range for the VPC, add subnets, associate security groups, and configure route tables. A subnet is a range of IP addresses in your VPC. You can launch AWS resources into a specified subnet. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. It therefore imposes no availability risks or bandwidth constraints on your network traffic. A VPC endpoint enables you to privately connect your VPC to supported AWS services and VPC endpoint services, powered by private link without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. Instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other service does not leave the Amazon network. Next is Elastic Load Balancer. A load balancer distributes workloads across multiple compute resources, such as virtual servers. Using a load balancer increases the availability and fault tolerance of your applications. You can add and remove compute resources from your load balancer as your needs change, without disrupting the overall flow of requests to your applications. Elastic Load Balancing distributes incoming application or network traffic across multiple targets, such as Amazon EC2 instances, containers, and IP addresses, in multiple availability zones. Elastic Load Balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to the vast majority of workloads. You can configure health checks, which monitor the health of the compute resources, so that the load balancer sends requests only to the healthy ones. You can also offload the work of encryption and decryption to your load balancer, so that your compute resources can focus on their main work. Elastic Load Balancing supports three types of load balancers: classic load balancers, application load balancers, and network load balancers. Classic Load Balancer provides basic load balancing across multiple Amazon EC2 instances, and operates at both the request level and connection level. Classic Load Balancer is intended for applications that were built within the EC2 Classic network. Application load balancers are best suited for load balancing of HTTP and HTTPS traffic, and provides advanced request routing, targeted at the delivery of modern application architectures, including microservices and containers. Network load balancers are best suited for load balancing of transmission control protocol, user datagram protocol and transport layer security, traffic where extreme performance is required. Next, Amazon Route 53. Amazon Route 53 is a highly available and scalable DNS web service. Route 53 is used to perform three main functions in any combination: domain registration, DNS routing, and health checking. It is designed to provide an extremely reliable and cost-effective way to route end users to Internet applications. Amazon Route 53 connects user requests to infrastructure running in AWS, and can also be used to route users to infrastructure outside of AWS. It can also be used to configure DNS health checks, to route traffic to healthy endpoints, or to independently monitor the health of an application and its endpoints. For more such videos, subscribe to our channel.